use integration by part to show that these questions can be getting in terms of this form of answer. So for integration by part, we have to select what is our u and then what is the remaining part of this integral as dv. So we will follow the rules of log, where log, then polynomial, exponential, and trigo. So we can see polynomial come first. So our x will be selected as u. So the remaining part of this, which is e to x over square root of e to x plus 1 dx will be dv. Then for u, we're going to differentiate u respect to x. So we get 1. Find out du, which is equal to dx. Meanwhile, for this dv, we need to integrate both sides to find out what is our v. So from this, we can simplify our function, where we can write it in more easier way to see here is e to x plus 1 power of negative 1 over 2. Because you can see this fraction, denominator is not only power 1, so it will power negative half. So this question can be rewritten in this form. And then from here, we can try to use our formula in giant function. So our giant function formula states that if we have an integral of a function power to something, and then at the side here is a differential functions. So from here we can integrate straightly using formula, which is power plus 1 over the new power for that whole function. So from here, we're going to select the function as e to x. So when we differentiate it, differentiate exponential, salin soalan, differentiate power, we get 2. Then differentiate 1, we get 0. So we're supposed to have 2e to x at the side here. So we have it. But we have to modify a bit, where we need a coefficient of 2 in order to get this pattern. So the next step, we're going to multiply 2. And this question we're going to divide by 1 over 2 to balance back the value. So after we get this pattern, means we can straightforward for integrate using formula. So for this side, integrate dv, we get v. So for this side, it will be 1 over 2 to integrate this giant function, formula number 7. And then at the side here is a differential function. We can power plus 1. So when we power plus 1 over the new power, so 1 over 2. Then we can notice that these 2 can be simplified. So means that our e here only is square root of e to x plus 1. Then we proceed to our formula of integration by part. So our formula is, for this integral, when we're using integration by part, it will be u v minus integrate v du. So where our du is dx. So you can notice that we are nearly to this answer already. We have this term, but we still haven't complete to show this format. So we have to continuous alter the questions. So in order to integrate this, It will be equivalent to the function divided by its square root function. Because you can see for e2x plus 1, to get the power of 1 over 2, so actually it will become from 1 minus 1 over 2, so that you can get 1 over 2. So we rewrite this square root to square root of exponent 2x plus 1. It is equivalent to that function divided by its square root function. So you're still having the function of power of 1 over 2. So this is power 1. Divide means we minus 1 over 2, so it will be equivalent back, but we need this pattern so that you can see this integral. It can give you the value that we want. So next we simplify this function so that we can get this pattern. We separate this division, which is e to x, divide the function, and then so actually this is minus, so this one here also minus for integral 1 over e to x plus 1. We separate this, so we divide this term divide by this, and then 1 divide by this. So you can get the pattern that we have done before. When we integrate e to x over square root e to x plus 1, we can get the answer of square root e to x plus 1. And then indirectly, for the last term here, we achieve as the question stated here, which is integral of 1 over square root e to x plus 1. So now we only have to multiply here so that we can get the pattern in this question. We are going to factorize out your square root e to x plus 1 so that you are having x minus 1 when you factorize e to x plus 1. Therefore, finally, we get to show. So for our marks here, it will be the first thing very important, how we select our u and dv. And then to integrate here, to find out our v, we use our formula, concept of formula to get this integration answer. Then we apply our integration by part formula, and then we try to separate it, simplify and separate it, so that you can use back, you can find this situation, relate back this integration that we have done it before. So this is your 1 mark. So finally you get to show this as your answer.